Our focus is on eBGP multi-hop and then followed by peer group. Peer group is not that important, but peer group helps to configure um, in a bulk. If you want to configure a similar thing with many neighbors, if you want to configure similar thing with many neighbors, we create a peer group as a template and we call the template, and then we attach the template to the neighbor and boom, it gets activated in single process. When we don't use peer group, what happens? We say neighbor address, remote AS. Okay, it processes, fine, remote AS is this. Next, neighbor address, update source loopback 0. Then it changes the update source to the loopback address. Again, neighbor address, we may say like use this distribution list. Now it goes and again recalculates as per the new change. So every time we disturb the process. But when we use peer group, we create a template in which we have the remote AS, update source, next up self, then distribution list, and then some other route policies. And then we simply call that template to a name, and then boom, everything gets activated in one go. Everything gets processed in one go. Now, we are going to now first, cover this eBGP multi-hop. I'll take two routers. This is a rare case, having dual connection to the same router back to back between two eBGP neighbor. And we will use a loopback interface. For example, 1.1.1.1/32, 2.2.2.2/32. We'll use the loopback interface to form peering between this router. And then we will proceed from there. Let's get into the to have this loopback to loopback neighborship. What is needed first? Reachability between this loopback address is needed. So we will write two static routes because we got two connections. We'll write two static routes and provide reachability. So even if one link exists, our neighborship will prevail. Our neighborship will continue. That's the idea. So we are going to write two static route and we are going to form neighbor using this loopback interface address, followed by the update source command. Remember, whenever you are forming neighbor using loopback, we have to source it from the loopback. Yeah, so we need to use update source command. Even after giving these things, the neighbor is not going to come. The neighbor is not going to come till we increase the TTL value. The default TTL value is 1 only. See, if you go here 1 hop, you will find the neighbor. Then why it is not forming neighbor? The reason is when the TTL is 1, the routing information base should show you directly connected. 2.2.2.2 should be seen as directly connected on router 1, which is not possible, no? 2.2.2.2 is a loopback interface address of router 2. When 2.2.2.2 is seen in the routing table as, go to that next hop or go via this interface, then these routers cannot form neighbor because it won't even send the packet out. If the TTL is One, the routing information base will expect the destination to be seen as directly connected. So when you say eBGP multi-hop 2, you break that limitation. Yep, then the packet will go. We break that limitation. So this is what we're going to see. So new interface is interface G2/0. Now shared IP address 10.21. That's what I say. But I still have the 12 there. I don't know how I did this. 21. 21.0.1, 255.255.0.0. Now on R2, G5/0. Alright, now we got the BGP already running between these two routers. I'm going to remove that. Show run or show IP BGP summary. You see, we got an eBGP using physical interface address, which I want to remove. Router BGP 20, no neighbor, this. Sorry, this. I removed it. So we don't have any more eBGP. Likewise on R1, router BGP 10, no neighbor 10.12.0.2. Next, show IP BGP summary. Right. Let me ping 10.21.02. Ping 10.12.0.2. All right. What? Now, next is, as I said, we should have reachability between loopbacks. Do we have a loopback interface? We do. Let us form neighbor using this loopback interface. 11, 11, 11, 11. Now, what is the router ID? What is the loopback we have in router 2? Show IP interface brief. Okay, there is no loopback. Let me create interface loopback 0 IP address 22. All right, the reason why I need this loopback is just to form neighbor. Now this address need to be a pingable address. It should be reachable. This address need to be a reachable address. What do we do for that? Static route. I'm saying IP route 11, 11, 11, 11. Send the traffic to 10, 12, 0, 1. Also 10, 21, 0, 1. That's it. Likewise, I'll go to router 1 and say IP route 22, gateway is 10.12.0.2. Likewise 21. All right, so where are we? We got the static routes. I should ping the loopback first. Ping 22, 22, 22, 22, source 11, 11, 11. All right, we got reachability. So the first thing is clear. For TCP packets to reach, we need IP path. It is given. Secondly, we need to define this neighbor by going under BGP. Router BGP 10. Your neighbor is 11 remote AS. He belongs to 20. Oh, sorry. Can someone tell what mistake I did? IP address of the neighbor is wrong. It should be what? 22. So it is good it didn't take it, okay? I didn't accept my configure. Alright, now, whenever we speak to the neighbor, we want to source it from our loopback. You know why? Because in router 2, our neighbor is going to be 11, 11, 11, 11. Which is in loopback 1, I think, loopback 1. What? Maybe loopback 11. That's the interface name. Yeah, loopback 11. So you should know the name of the interface. You see, hi, let me show you. Do show IP interface brief. Loopback 11. Next, we have sourced it, but the packet won't go. To prove that, let me show you. Debug IP BGP packets. Debug IP BGP IPv4 packets. Unicast. Keep alive events. Nothing will go out. Why it won't go out? You see, show IP BGP summary. This is not. It is not written like this. For 22, if it is written like directly connected here instead of via 1021, if it is directly connected, it would have established neighbor, it would have sent a packet, because when TTL is 1, it should be shown directly connected. Next, the packet won't go in, so it's nothing is going in, nothing is going out. Show I debug. What is this debug? It's a regular scanning timer, right? There is no packet TCP packet going out. Next, going to router B. Router BGP 20, neighbor is 2011. Neighbor 11. Update source. I think I gave you bug 0. Fine. Now let us now enable debug here. No, here I do not want to enable debug because we got another high BGP that will come. I don't want to confuse. So R1, if you see, it is not sending any TCP packet. First, it should be a TCP three-way handshake packet, but no three-way handshake is going. So solution is, update source is not enough. You also need to increase the TTL. Show IP BGP neighbor. As of now, the neighbor is not ready. It is idle. Remote is not discovered yet. And what does it say? The RIP does not have route to 22. But we have route now. Why it is showing like this? It's not having a route actually directly connected. That's it shows like this. See, the external BGP neighbor not directly connected. How friendly the outputs are. So there is no active TCP connection. Now let us go and sorry and say this command neighbor 22 22 22 22 EBGP multi-hop 2. As soon as I say this, even if I say one side, the neighbor will come up. Why? Because it's a TCP packet. This will go and talk to that guy, and that guy is going to respond back. It's a TCP connection. No, 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 sir. The directly connected is no more a constraint after you say this. Static road won't be shown as directly connected. Expecting the route to be directly connected will not be anymore an expectation. Hmm. So, Sheikh, finish your question, please, faster. Okay. ஐயா தமிழ்லயே சொல்லுங்க தமிழ்ல சொல்லுங்க tell me in தமிழ் இங்க பாருங்க 22 22 22 22 தான் நமக்கு நெய்பர் அது எந்த வகையிலயாவது டைரக்ட்லி கனெக்டடா ரவுட்டர் 1க்கு இல்ல in order to reach 22 22 it has to use any one of this physical cable, correct? But this physical cable network is not our neighbor network. So this physical cable showing directly connected is of no use for us. For us, the neighbors 22 network need to be seen as directly connected on R1. Only then with the TTL of one packet will go out. When there is no chance, when there is no option for you to have 22 22 as directly connected, you need to simply go and break that rule, TTL rule. So when you change eBGP multi-hop to what you are really telling to BGP is BGP don't expect this 2222 to be directly connected in the routing table. That's the implicit meaning of this. Implicit meaning என்ன மறைமுகமா சொல்றது என்னன்னு சொல்றீங்க ரெண்டு ஹாப்புப்பா ரெண்டு ஹாப்னா அது எப்படிப்பா நேரா கனெக்ட் ஆயிருக்கும் அது எப்படி டைரக்டா கனெக்ட் ஆயிருக்கும் so when it is two hop how there is possibility for directly connected so BGP will say fine okay you want me to check neighbor even more than one hop fine then let me send the packet now. So it will send the packet, at least it will send the packet after you say this. Sir, you have any questions, sir? No, no, our yeah, please. Yes. Mm, correct. Exactly said. You see, but it's not a good practice to leave it like that. Let me finish our. Um, I was telling that if I have just one side configured, now router 1 will decide to send the packet out because I say TTL2. Router 1 will send a sync packet with a source address of 11.11.11, which is also matching here in the neighbor statement. And neighbor will happily respond to me with a SYN acknowledgement and then followed by sync packet. So the three-way handshake is successfully happening even if any one of these neighbor initiates. If three-way handshake is done, then they have no problem now in sharing the open message and sharing the updates and establishing the connection. But the problem will be, what if this neighbor removes this command accidentally or some reason? So what I'm coming to simply say is, do this on both sides. Because it is TCP, if you do it on one side, it will come up, no doubt. But for some reason, if that one side, that one command, one line of command is removed, then you lose the neighbor. But if you would have configured on either side, if one side is somehow mistakenly removed, it is okay, the other side is still there. So good practice is to do it on either side. Sheikh you understood this? All right. Now let us, yeah. No, I understand what you are saying. See, once the three-way handshake is over, they don't expect that neighbor to be directly connected in the routing table. See, R1 has gone to the other side with the port number 179. The sync packet goes to R2. Sync packet port number is what? 179. What is the source address? 11.11.11. And it is matching in router 2's neighbor statement also. And router 2 responds back with SYN ACK. Very important acknowledgement it is sending. Not only that, it is also sending, hey, this is my SYN packet. Can you give me an acknowledgement? So R1 gives an acknowledgement. Now this is what they need. They got the security connection oriented. Now they don't stop for any other reason. Application layer protocol. Hmm. Correct. Exactly. So now let us move on to the second router. Okay, before that I hit enter. I did not configure on R1 and you will see neighbor coming up. And I also enabled debug and I'm expecting now the debugs to show some multicast based service reset request. But it won't take this long. Let me check whether I have put everything right. Show IP BGP summary. Okay. And then show run section router BGP. Now what do we have is 11. That's the advertisement. That's okay. EVGP multi-hop to update source is given correctly. What about router 2? Show IP interface brief. Loopback 0 is 22, that is right. Show run section router BGP. I have said update source and remote AS. Remote AS and update source is given. Why there is no neighborship? Let me try pinging. Ping 22 to 22 to 22 to sorry 11 11 11 11 with the source 22. Okay, it goes. Reachability is there, but it didn't come even after configuring on one side. But usually it comes up. I just want to check anything is missing. Show IP, or let me put some other debug. Debug IP BGP. All. Okay. Okay. So it says active open failed. Why? Neighbor global active open failed means neighbor is not ready to form neighbor. So this is saying BGP 2222. Actually, three-way handshake is over. It is sending an open message with the local address of this. The open failed, connection refused by the remote host. Connection is refused by the remote host. It's not available. No, after three-way handshake, only the open message will be sent. So if it says like this, which means this operating system needs both side configuration. Really? But why? Let me try once. Router BGP 20, neighbor 11, 11, 11, 11. Updates, so sorry, EBGP multi-hop. Oh my god, the name is coming up. Only after configuring on both sides it comes up. But I've seen in a lot of operating system, if you configure on one side it comes. But here, even the open message is checking for directly connected. Even the open message is checking for directly connected. So both the side we have to configure. EBGP multi-hop 2. Now, you might have seen a lot of packets here. Turn it to active and active to idle, or here. The neighbor has come up because I turned off the debug. Sorry. So the neighbor has come up. Show IP BGP summary. Neighbor is up. Show IP BGP. This router is advertising that same 11 network. I don't want this interface. Loopback 111. IP address 111. Router BGP BGP 10, no network 11. I'm removing this 11. You know why? We have a static route for 11 on R2, so it will show RIP failure. So I'm removing it. I do not want. We'll talk about RIP failure a bit later. I'm expecting R2 to now show me the route to reach 111. Show IP BGP. Yeah, we got the 111, the newly enabled loopback interface on R2, and show run section router BGP spelling mistake. Now when we have next hop self to this neighbor, only then router 3 will have in the routing table. See, in the routing table I don't see 111, but in the BGP table I will have it because I learned it through BGP. But the next hop is an unreachable next hop for router 2. For router 3. For router 3, this is unknown destination. So what I need to do is I need to do only on router 2. See, if I have many routers between router 2 and router 3, you don't need to do it on every router. I remember one of you were asking this question. You do it only on your edge router BGP 20, neighbor 10.23.0.3, next up self. After saying this, you see, this is how we reset the neighbor. Sorry, not resetting the neighbor like destructive method. We called a soft reset, clear IPBGP star soft. This will do what? This will go and refresh all, that star means all BGP neighbor. To all BGP neighbor, it will re-establish the neighborship from the beginning, but it won't terminate the old session. Without breaking the present neighborship, it will simply resend all the open message, the keep alives, the TCP, the update, all once again, all the attributes once again. So this is called soft reset. If you don't put the soft, it will discard the neighbor and re-establish the neighbor, which is a disruptive method. Hard reset is not good. See, it brought down the neighbor went down and then it came up. You can also do it for one particular neighbor. You see, clear IPBGP neighbor or clear IPBGP uh, IPv4 and then neighbor unicast neighbor address. What I'm not seeing. Clear IPBGP. I can say neighbor address. Where are you? Yeah, you see, we can give directly neighbor address. There is no command neighbor, so that's what 11, 11, 11. It will re-establish the neighbor by breaking the neighbor. It's called hard reset. See, neighbor goes down and comes up. We can also mention soft, so that without killing the neighbor, it will resend all the update. Now let us go to router 3. By this time, update should have gone to router 3. Show IPBGP. You see, the next hop is changed. And now I see the greater than symbol, which was not seen earlier. Earlier it was not seen, and the routing table was not having a route earlier. But now the routing table also will have the route. But will I be able to ping from here? I cannot ping from here. Why? Can someone answer this? I'll not be able to ping this 111, even though the route is there. I won't get the reply. If I ping from here, the ping fails. Why? I expect something better, more better answer. If I ping, the ping will not be successful. Why? When you ping from R3, what will be the source address? See, if I ping here, now if I ping like this, the destination address is 111, What will be the source address? Correct, 10.23.0 network. This 10.23 is unknown to router 1. Yeah, Sheikh Ji? Router 1 don't know about this 10.23, do they? They don't. They don't know. They don't know because they're outside, no? Sheikh, you understand or not? So because R1 don't know the source from where the packet is coming, R1 will not be able to respond back. See, if I ping, the ping will go, but the ICMP echo response will not come. See, I want to debug IP ICMP, and now I'm going to ping it. You see, the packet will come here. See, the packet comes here, and this echo reply is sent back from this source to this destination, but the destination is unknown. You see, ping 10.23.0.3. It's an unknown destination. As a result, on R3, you see there is no ping successful. So if you want this ping to be successful, either you advertise this 10.23 on router 3, or you create one loopback and advertise that. Let me advertise this router BGP 20 network 10.23.0. Yeah, but they won't agree, no? The neighbor autonomous won't agree, no? So we'll say 0 and then mask 255.255.255.0. Now if you ping from here, the ping goes. Boom. Give some time, it will go. Once BGP advertises this 1023 network, first of all, let me check the mask. Show IP route. What is the 1023 mask? The 1023 actual mask is 16, not 24. Here it is mistakenly written as 24. 16. Okay, so I need to change the network statement. Router BGP 20. I remove this. Instead, I put 16 mask. Now the ping will happen. Right, now let me try pinging this. Before I ping, I want to go to R1 and show you the route in the routing table now. Show IP route, BGP, show IP route, BGP, you see. You got the 1023 route now. Earlier it was not there. So now if I go to R3, the ping goes successfully. Now, we have learned only one thing, that is how to override that TTL one problem. How to override that directly connected problem. If I have a loopback interface to loopback interface neighborship, that security concept of TTL1 becomes a headache for me. Even though it is good, but for us it is not good because we are not ready to form neighbor using physical interface. So to override that, we are putting eBGP multi-hop 2, and we are able to do the peering. I want to add something more to what we have learned so far to this TTL thing. You see, currently, when I take you to router 1 and show IPBGP neighbor, we have increased the TTL to 2. We have increased the TTL to 2. So when R1 send the packet, it will send with the TTL of 2. What is the use? See, this is a solution to override the directly connected limitation, but it is not a secured one. You know why we have TTL? TTL is to prevent loop. Not only that, TTL is also for security. We do not want to form neighbor with someone from the remote. Like I said earlier in the previous class, few weeks back, BGP hijack happened in somewhere in the globe. I don't know exactly the location. BGP hijack. So when we know with whom we are handshaking, then there is no possibility of attack, hijack. So to limit someone from coming from very far place, handshaking with us, the TTL is there. It is good to keep the TTL as low as possible. We should not send the BGP packets out for many hops because attackers may be waiting in that hop to negotiate BGP with you and give you routes that are spoofed, not truly present. See, recently I saw one knowledge-based video in YouTube. Like you should not scan the QR code, and when you scan some QR code on the roadside, thinking that it's a QR code for paying the parking. You know, country like Dubai and many more countries, we pay for parking on the roadside. So what people do is some bad guys, they put QR code near the parking area so that you will think that it is for parking. As soon as you scan it, it shows a link. And when you press the link, they have developed an app which is pretending to be a parking app, which is not true. So you thought, okay, it is a parking app, we have to pay anyhow. And you started typing your bank details or whatever. Now that app is listening to all that you do, the credentials that you type to pay, everything. After some time, they loot everything from us. So we should check twice that this is the right QR code for parking. I just took parking as an example. You might have seen in shopping malls QR code. In country like Sweden, many years before I bought chocolate, I was surprised there was no one to receive money from me. All that I need to do is drop those chocolate in a basket and scan the QR code there, or keep the card, and it automatically takes the money from my bank. It was amazing. You might have seen already. You are all living in a grown-up country. In India, it has already now only come. It has come to India now. A few Decathlon has got this. So why I'm taking in different directions? See, for small purchase, you need to think twice whether I'm scanning the right QR code. Like, think BGP. BGP is the one which is behind the internet. The reason for we to have the route in the internet. If our routers handshake with the rogue rogue BGP rogue BGP peers, problem. The entire world will be in problem. So TTL needs to be properly handled. Now what we are going to do? Sending of 2-hop. I'm going to send my packet 2-hop. What is the use for me? I need to see whether the incoming is less than 2-hop. Outgoing, why I need to worry? Is my neighbor coming to me? Is he within 2-hop limit? That is important. So this is not good. What does it show? 0. What does it mean? The neighbor can be 255 hops anywhere. When you will get 0, if incoming is 0, what does that mean? It is ready to accept 50, it is ready to accept 200, it is ready to accept 1. Meaning, if someone is sending a packet with 255 hop, to reach you, if there is 255 hop, only then you will get TTL of 0. It's very dangerous. EBGP multi-hop 2, you simply say, and you open gates for attackers. What attacker is going to do now? Because you are ready to accept any TTL as an incoming. When a packet comes, you don't care about how many hops away he is coming from. From how many hops he is coming. You don't care. You don't have a checking mechanism for incoming, only outgoing. It's not secure. So what I'm going to do is I'm going to do in a secured way. I'll remove the EBGP multi-hop command and I'll show you how to do the same thing in a secured way. R1 and R2, I need to show you routing table, right? Show IP route, BGP, yeah. And R2, let me show you. Show IP route BGP, yeah. Why in router 2 I am not seeing 10.23? In router 1 I see 10.23. Why I am not seeing in router 2? It is because it is directly connected. It's directly connected. That's why. Okay, now let us go to our story. I'll go to router BGP 20 here and I'll remove the EBGP multi-hop statement. Likewise, I'll also remove from here. Router BGP 10. I removed it. Now I'm going to refresh BGP because it will take 240 seconds to remove the neighbor. 240 seconds is the hold time. See, do show IPBGP neighbor. You can see here the hold time is 240 seconds. Sorry, 180 seconds, not 50, 180 seconds. Instead of waiting for 180 seconds for the neighbor to refresh, see, I've changed the TTL value. Let me show you. In this output, we can see. I changed back the TTL value. I removed TTL2. Now, I'm going to say do clear IP BGP star soft. Now I lose the neighbor. Now hard reset will also do for this. I have done hard reset. Finish. The neighbor will never come up because of the TTL. Do show IPBGP summary. You see, the neighbor is idle. Now what I'm going to do is I'm going to say neighbor 22, 22, 22, 22. neighbor 22, 22, 22, 22. Instead of saying EBGP multi-hop, I'm going to say TTL security hop 2. What does this mean? This means that neighbor, whoever comes to me, he cannot be more than 2 hop away. He should be less than 2 hop away. What does it mean? This TTL incoming, I don't care about outgoing. This TTL incoming, I'm changing it as 253. 255 minus 2. So if someone is coming from 2 hop away, then incoming TTL will be 253. Yes or no? If someone is 2 hop away, when I receive the packet, what will be the TTL value? 253. Less than. No, any one is what you need to configure. You need to configure either EBGP multi-hop or TTL security. See, what I have done is, on this router, what I have done now is, I said outgoing TTL 255, meaning I'm ready to send any number of hops. I don't care. But my neighbor who is coming should come from 2 hop, which is 253. See, when it's sent from here, it becomes 254. When it's sent from here to here, it becomes 253. So that is what it is going to show me now. If I type, okay, let me finish on R2. Neighbor 11, 11, 11, 11, TTL security hop 2. Now let us go to router 1 and check show IPGP neighbor command. Now the neighbor is established, and if you see the wonderful part of TTL here, this is more secure. It says, if someone is 252, I will not accept. If someone is 253 or 254, I'll accept. Which means if someone needs to be accepted by me, he cannot be more than 2 hop away. Did you understand that part? All right. Sheikh. Yeah. So we don't care about outgoing now. We only care about incoming. That is what we need. If everyone checks what they get, then everyone is safe. So if you want secured loopback to loopback peering, instead of using EBGP multi-hop, use TTL security. Let me show you the command. Show ran section router BGP. You see? TTL security hop 2. Yeah. Correct. Because usually when packets are sent, the outgoing is 255 when you put this command. You should put the same command on the other side. Don't put one side EBGP multi-hop, another side TTL security. No, that won't work. Yeah, you understand? Both the neighbors should follow the same rule so that both will send with the outgoing of 255. When it reaches here, it will be 254. And the minimum it will accept is 253. It won't accept less than that. See the word itself, in the keyword itself, TTL security. They have named it so nicely. The command TTL security. So follow this one instead of EBGP multi. Right. So we'll stop here.